This is Greg Pasternak from Riverside Life. It's been 3 years since I posted my last video, and I'm really sorry about that. It's actually not for lack of recording videos, it's just for lack of time to find the way to produce all the videos to make something worthwhile for you to watch. So anyway, I'm back now, and I have a lot of videos I've recorded over the last 3 years that I just haven't had a chance to put up. So I'm going to be chipping away at getting these produced. I won't always be introducing them, but I probably will try to do a bunch today, just get a bunch out for you. In this first video, what I've got for you is a continuation of the topic of where do channels begin. But in this video, we're going to be looking at why water doesn't just begin as a channel like as soon as a raindrop hits the ground. And it has to do with the precedence of like the fact that the landscape is very holy. Not holy in the sense of, a godlike deity, but holy in the sense of having lots of holes. So I'm going to show you two different landscapes. One is the one we've kind of already been looking at in the Oakland Hills of California, showing you what a hill slope looks like there, all kind of dug up by organisms. And then the other is going to be from a trip I took to Japan in 2018. And you can really see in a beautiful natural forested landscape how the surface is just not even a surface. It's like a Swiss cheese or a sponge. So let's take a look at these videos, and I hope you enjoy it.
When we think of a hillside, we usually think of it as being flat and relatively smooth. But in fact, it isn't flat, and it certainly isn't solid. If rain was falling out of the sky and it was hitting the ground here, look at what it's going to hit. It's going to hit this big pile of very loose dirt. Now this dirt, it's not just loose because the hillside is composed of loose dirt. It's loose because of what we call bioturbation. That is that bugs and animals and other kinds of insects and things are all burrowing into the ground and churning up this material. Worms would be another good example. And as a result of that, when water hits the ground, it's much more like a sponge than it is a flat, solid surface like a concrete. And that really affects how you think about the surface of the ground. It's more of like a doorway than it is a barrier or a wall. Water can flow through it relatively easily to go down. So when you see that surface, don't imagine in your mind's eye that the water is running off of that surface when the rain hits it. Imagine that it's being slurped into it just like if it was going into a sponge.
This is Greg Pasternak from Riverside Life, and I'm here today in the Japanese Alp looking at macropores on steep mountain hillsides. Macropores are places where there are holes in the ground so that the water doesn't just flow on the surface anymore, they go underground. And there are macropores just all over the place. Not only are there holes in the ground, but there are places where there's a lot of debris on the ground, and that forces the water to not flow right on the surface, but in that debris, under the root zone, or in these deep holes. Here's a view showing the typical kind of debris, and you can see how there are these holes that open up in the root network as trees go on top of trees and dead wood that's also on the ground. And then if we turn around, we can see here some holes, and I'll stick this hiking pole here, that the water just goes into these holes and then it flows underground for a ways until it's going to resurface somewhere down the slope. So macropores are very important because they change where channels can begin by shunting water underground. And it's a highlight of the importance of groundwater flow and understanding where channels can begin. Here we have a large macropore, which is an opening in the ground where water leaves the surface and goes underground. Macropores can come in all sizes, and you never know when they go down how far they're going to go. But you could see, I've got a pretty long length of pole heading into this macropore. We don't know if it's going to reappear just a few meters down the slope or quite a ways. But this is one of the reasons why the idea of where channels begin is not just about where there's enough contributing area and local slope, but how is the subsurface flow taking place? So I'll keep hiking and we'll see if I can find more of these macropores. Here's another example of a pretty deep macropore. Again, it's hard to tell where it goes. It just goes down under the ground for a pretty good length of this pole. On the other hand, some of these open spaces just go straight through and come out on the other side. So there's just an incredible amount of diversity and complexity to macropores, and they really change the physics of how water flows down hills in well-vegetated areas, as well as just wherever you have organisms digging holes in the ground. Here's a whole line of macropores running along a contour. We just have layer upon layer upon layer of rocks and tree stumps, dead wood laid over. And in fact, we're on a boardwalk that keeps us on top of all that, because there, where is the surface under all of this material? You couldn't even walk here, and if you can't walk here, then water really can't flow on it, which sort of means that many of the equations we use to predict and understand flow wouldn't even apply in this setting. So that makes hillside hydrology just incredibly complicated to deal with. I mean, look how deep this just goes down and down and down, probably 3 or 4 meters down into that hole.
Okay, so I hope you enjoyed those videos. I will do my best to try to come back with more content, and I'll even be trying to produce more today as best as I can. So you may see this shirt, and that's how you know I did it all on the same day. If I changed my shirt, well, it's been a few days.